Hello everyone, good evening. Welcome to this session. It's about resilient observability at the retail edge, a lightweight, scalable, and cost-efficient framework. So the session is going to be flow like this. The edge observability problem. So why retail edge monitoring is uniquely hard? When it compared to the on-prem or public cloud provider, there is no such problem, right? On the retail edge, so we have to work with the limited resources, what we have, so it's uniquely different. So we'll start with the problem statement, then we'll move into infrastructure modernization. So these days, retail organizations from bare metal or virtual machine they started leveraging the Kubernetes, like similar to on-prem to cloud migration or in the public cloud provider. So we'll talk about that. Then we'll go through Prometheus with OpenTelemetry. When we talk about Kubernetes, Prometheus is the default scraping mechanism for metrics, right? But how that failed in the edge platform, where resource constraints are there. But how OpenTelemetry stepped up and gave that end-to-end visibility. We'll talk about that. Then we'll go deep into OTel for not only for traces, but metrics, trace, logs from end-to-end visibility perspective. Then we'll talk about front-end observability, right? So whenever observability comes, user experience is a main thing, right? It always based upon how user is feeling your application, how's their performance, all those. So we'll talk about that. Then finally, results and lessons. So this framework is implemented is one of the largest retail environment in the United States. So we'll talk about the results from the production environment and what we learned over a period of time. First, we'll start with edge observability problem. So as I said, when we talk about the on-prem or public provider, so we can install all sort of monitoring tools, telemetry components to collect metrics, trace, logs, everything, right? Because we have enough resources available. From scaling perspective, you can do horizontal scaling, vertical scaling, all those things you can do. But this edge environment, we are talking about, the infrastructure present within the four sides of the wall, right? It could be a healthcare, or hospital, or your financial institutions, right? You don't have that luxury, right? And again, we are talking about tens and thousands of retail environments, where if you wanted to invest in the infrastructure, we are talking about millions of dollars, right? Where no organizations want to invest in a short period of time. So we are talking about that environment, right? So in that environment, if you wanted to capture the metrics right from the user interface to the workloads running within the edge and all the way to the central, on the edge, we have to play with whatever we really have, right? So we have different amount of CPU, memory, storage, all those things, right? So that's the main challenge. Then when we talk about the network bandwidth, right? Yes, you installed all the telemetry components, right? And you want to send it to some central location for dashboarding or alerting, predictive analysis, all this AOps perspective, you need to have it in a central location, right? So that's another challenge. So when we are talking about the retail environments, right? And not necessary, environments in rural or urban, you can expect like ample amount of network bandwidth available, right? Some rural environments, you are talking about only certain amount of MBBs, right? And when we talk about that, the precedence always comes the traffic for the application, right? They wanted to send the application data first and voice-related data first. And unfortunately, telemetry component is always least in the list, right? They want to send it. So that's another problem we have to deal with. Then comes to the tooling complexity, right? So we have a lot of commercial products available, right? And although many things are there, but when it comes to the customization, right? We only have limited things, right? So it won't support the customization how you wanted to perform, right? So that's one thing. And also when we are talking about the scale, it's so expensive. It's so expensive. And also the services or business transactions, right, which collects from across all these things, there is a limitation. Up to 50,000 BTs only you can collect or some certain services. So that, to scale that to that level, so that much customization not provided by the commercial products. So that's another challenge. Although there are a lot of challenges are there, but we definitely want to collect all this data to see how our application is behaving from end user perspective, right? But still we need to collect that. All right, so that's a problem statement, but how, how these days organizations are leveraging the Kubernetes-based environment. So at one point of time, so all these environments, they have bare metal ESXi host or virtual machines, basically non-Kubernetes-based environment. And all those applications, it's coupled with each other. And if you wanted to do any modernization or capable or functionality-wise, so each are dependent upon each other. So, and there are only certain things you can do. So that's one roadblock which we had in the previous environment. And when it comes to collecting the telemetry data from those non-Kubernetes environments, it's really hard, right? Either we have to use commercial products, which we are already talking about the challenges, and these days, open source and cloud native compute foundation, all these frameworks are there, but mostly they are supported for Kubernetes or Docker-based to some extent, right? So then for the non-Kubernetes environment, if you want to use open source, we need to install exporter, right? To extract all those metrics and collect it, shipping it. And when we introduce a lot of exporters, obviously there is an additional point of failure. Then you need to allocate resources to those exporters where we are already in resource crunch, right? So that's another thing. Then hard to scale. So when you have more exporters, additional point of failure, and when we're talking about hundreds and tens and hundreds of environments to scaling, it's really hard. All right. So then another thing mentioned about the Prometheus stack, right? So we know Prometheus, when we talk about Kubernetes, Prometheus is the default OpenStack solution, which many of the companies even now also they are using it to scrape the metrics, right? But there is a problem there when it really comes to the using the same stack for the retail edge. So we'll talk in detail about that. The next slide. Okay. So what sort of modernization organizations these days are doing to leverage the cloud native and open source telemetry products, whatever available in the market. So one, the main thing is, right, companies are started migrating from bare metal to Kubernetes based, right? But at the same time, when we talk about the Kubernetes, not the full-fledged version of Kubernetes, there is something called K3s, or micro K8s. It's a basically mini version of Kubernetes, whatever is needed for the retail edge, right? So meaning like it operates, it has all the components needed to manage the Kubernetes infrastructure needed for the edge, but removing all the unwanted components, like to manage the whole-fledged cluster and the node pool, horizontal and vertical scaling, all those things, which are not really needed for the retail edge, those are removed and limited components are available, right? So this one, there are many vendors available. One of the popular one, you guys may heard of SUSE Rancher, right? So Rancher is one of the vendors or organization where they are providing the mini version of Kubernetes. So this works well for the edge environments where the resources are constrained. So this solution is based upon Kubernetes and it is leveraging the K3s. Then second, obviously, since it is Kubernetes based, lot of the metrics needed from application infrastructure perspective, it natively exposes the endpoint where we can scrape it, right? So basically, when you have an infrastructure with the Kubernetes, so minimum number of exporters dependency is there. So that's what I mean. And at the same time, not all the metrics, right? For example, if you wanted to scrape the database level, any Postgres, MongoDB, or certain things like that, and for those components or underneath the virtual machines where the K3 is installed on it, you still need the exporters to scrape that, but it's a minimum when compared to the full-fledged VM. It's a minimum. So that's one thing. And then This framework leverages everything is open source, including OpenTelemetry for logs, metrics, traces. And then in addition to that, this solution leverages Fluent Duet and FluentD. So again, this is an open source. This is to collect the logs from the backend workload perspective. All right. So now Prometheus was OpenTelemetry, right? So initially, when we try to implement this solution, or meaning like when we try to develop a solution which needs to be very lightweight with the amount of resource and network what we have, we initially tried with Prometheus, right? Because even in our on-prem private cloud and in public cloud, Prometheus is the default telemetry mechanism to scrape the metrics. So obviously we started with that, but it didn't play well, right? But before going that, we'll talk about the high level, the difference between Prometheus and OpenTelemetry. Most of the things are there, but from this solution perspective, we'll just highlight that. So for metrics, yes, it's a pull-based, right? And once the metrics are pulled, and we'll use Prometheus query language, either in Grafana or any other tool, and for an aggregation, alerting, dashboarding perspective. But OpenTelemetry, in addition to pull, it supports push mechanism as well. So meaning like, if your in your workloads, if you have instrumented OpenTelemetry with the SDK, in addition to the collector where it can go and scrape the metrics, from your application code itself, you can send the metrics to the endpoint, right? So that reduces some load on the collector side. And it's an vendor agnostics. So meaning like it can go to Prometheus backend data source. It can be any of the public provider. But in addition to that, there are many third-party vendors are available where it can just intercept the data comes from OpenTelemetry and for further processing. And we all know, so the metrics is one of the 3 pillars of observability, right? And when we talk about the traces, so Prometheus doesn't support that, right? And but OpenTelemetry, yes, with the SDK, it support collecting the traces, and it can send it to Tempo as an Grafana-based backend solution, or you can send it to any commercial third-party products, Datadog, Dynatrace, those kind of things. Then logs. Logs again, Prometheus doesn't support, and OpenTelemetry, it has an SDK to collect the logs as well. Another thing, so for an end-to-end observability, it is important to collect the metrics, stars, logs, everything from the user interface perspective also, where Prometheus doesn't have that capability. And when it comes to the OpenTelemetry, so the SDK still supports that. And in addition to that, web vitals, right? So Google introduced this concept a few years back, and to measure the performance of the end user from the digital perspective, right? Either it could be a browser-based or native mobile-based. They have introduced something this called web vitals. So it has multiple metrics. So that's a latest or modern way to measure how your application is behaving from end user perspective. That OpenTelemetry still supports that. In addition to that, yes, it collects sessions right from the user interface and all the transactions, spans it is going through. Right. So why I mentioned all these things, right? These next 2 things are really important. So since we started with Prometheus to collect the metrics, the amount of resources where Prometheus needed just to collect the metrics itself, it was like around 3.5 gig, right? So we are talking about resources on the retail edge where you have, approximately say 25 gig or 50 gig of memory, right? So if you have that much resource constraint, assigning about 10 or 15% of the resources just for Prometheus, and that too just to collect the metrics, is just too much, right? Again, we need to deal with traces, logs, everything, right? So Prometheus, we cannot afford that. So we tried a few mechanisms, which we'll talk about in the few slides. And after we hit the dead end, we tried, okay, so with Prometheus, it's not possible. Either we have to look for alternate solution. That's what we ended up with. Okay. Then we started looking into what other options we have, OpenTelemetry. So at that point of time, we are talking about almost 2.5 years back, and at that point of time, we looked around and checked with other vendors and all, other organizations and all, and many people what they told, yes, they were using OTel, but mostly for traces, right? And to some extent logs, but not really metrics. Metrics, everyone said Prometheus, Prometheus, Prometheus. So at that point of time, we didn't have a working solution, but we wanted to try, right? So we started with that, and initially we faced some challenges. It was not a smooth walk initially. We faced a couple of challenges, which again, the next slide we talk about that. But that solution worked, and it drastically reduced the resource consumption from 3.5 to 1.3 gig. That is not only for metrics, but traces, logs, everything, right? But there are some configuration enhancements we have done, and we'll talk about that in detail. Then when it comes to the network bandwidth, right? So resource is one thing, but at the same time, more than resource, network bandwidth was a major problem, right? So meaning we have all these locations, and we need to bring or ship this data to our central location, but we have a lot of dependency. When I say that, we have a lot of service providers, AT&T, Cox, which we have this for so many decades. And when we talk about the rural environments, and not much bandwidth available, roughly, we checked multiple, not only our company, we checked with, more than a dozen different retail environments, how they are using it, right? Because when it comes to our environment, we have about 25 to 50 Mbps of network bandwidth, right? From our locations to the central, or at least to the third-party service provider. And even everyone kind of like dealing with the same thing. Okay, so how to deal with that, right? So Prometheus, again, when we tried Prometheus for those metrics, just for the application metrics alone, right? No exporter, nothing, because collecting the application metrics was very crucial for us. When we tried that, just for few metrics, right? Not for everything. Some critical, like 4 or 5 critical application metrics alone, the bandwidth consumption was anywhere between 12 to 18 Mbps, right? And the total bandwidth available is like 25 to 50 Mbps, and we cannot allocate everything, right? And when we checked with our network team, what they told is, well, again, application traffic is important. What you get is 1 Mbps. That is your limit, right? With that, what we can do? Nothing. So again, that also made us to go to OpenTelemetry. And when we tried that, for the similar thing, the network bandwidth, it drastically reduced from Mbps to less than around like 600 kbps, right? So 650 is for everything, but around 550 kbps to 600 kbps was that the network bandwidth we needed for the same metrics where Prometheus was trying to collect. So that's another major thing. So these are like a high-level comparison of between Prometheus to OpenTelemetry. Why I'm reiterating that? This was like a basically major challenge what we faced when we tried to use the OpenTelemetry components to develop a robust observability solution from retail edge perspective. All right. So this is kind of like a summary how we achieved a solution, which is production scale across thousands of environments. So memory location, memory resource allocation perspective, it reduced from 3.5 gig to 1.3, which is a 63% savings. And similarly, network bandwidth roughly from 18 Mbps to 650 kbps, 96% reduction of usage. Then the main thing is, we are not collecting everything, right? If you take any monitoring solution, it can produce hundreds or sometimes like thousands of metrics, right? But are we really using all those metrics? Really not, right? When we talk about visualization from dashboarding or alerting perspective, barely we use like 5 or 6 core metrics, right? Other things may be useful for reporting analysis perspective, but to proactively monitor your infrastructure, our application, everything, if you take about infrastructure or application, other thing, 4 or 5 core metrics is enough for that. So basically, we have narrowed down to about 25 metrics, which will cover end to end from infrastructure, application running on top of it, database, everything. Right. So how we achieved that, right? So, okay, we decided we are going with OpenTelemetry, but again, that's not a smooth one. When we started implementing OpenTelemetry, right, while testing in our lower environment, so OTel, it has multiple components, right? You have an operator, collector, processes, everything. When we implemented that operator, no problem. It just installed, we got the GitHub repo code installed, fine, no problem. When it comes to collector, it didn't spin up. It was keep on crashing. And when we started, looking at the logs, why it is not coming up, then there was a couple of known bugs related to the collector, especially when you guys are using Google managed backend as your time series data source, right? I'm not sure about if you use AWS or Azure. This is specifically for Google because CVS, we are majorly, Google is our public provider. So we collect all this data and store the metrics in Google managed backend. So when we look into that, there was a known bug, which is there, documented in the Google itself, and they didn't have a proper solution at that point of time. And then we started obviously engaging with the support, all those things. But parallelly, when we're looking into it, okay, it's failing due to what, right? When we go deep into further, there were a couple of things. One, metric compatibility issue, right? When we collect any of the metrics, there are metric types available, right? Either it is an integer or double, right? Depends upon the type. So that type, when it goes to the backend, it will look for the existing metrics, and if there is any conflict, meaning we are collecting similar kind of metrics in Prometheus also, right? And we wanted to use the same backend data source, and when OTel tries to collect it, there are few metrics where Prometheus is collecting and storing as an integer type, and similar metrics, not similar, actually same metrics, OTel also tries to collect it, and when it tries to add it to the same backend, it conflicts, right? So that was the problem. And okay, so what was the solution? While looking at the metrics, two things we identified. One, those metrics are not really needed for our purpose on the retail edge. For example, if I can recollect, there is a container memory related metrics, one .RSS, something like that. And then few other OTel metrics, like a OTel scope, name, version, info, few other metrics. Again, these metrics also not needed. So what we have done, we have filtered them. We have filtered on the local collector itself. Don't send it to central, right? Because anyway, those metrics are not really useful, what we really needed. So we just filtered that, and after that, boom, it worked, right? Alternate solution, if we find these metrics are really needed, then what you could do on the local collector itself, convert the metric data type from integer to double or double to integer, So that way also it works. And in addition to that, we are capturing all the core metrics from the kube state perspective, then container perspective, application, from Istio is our service mesh layer. We are capturing all these metrics from Istio layer. Then node exporter we are using to capture the VM level metrics, right? How is the virtual machine where the K3 Kubernetes running, how the underneath host, CPU, memory, storage, and network. These are the 4 metrics are performing. This is what really needed, and we are collecting that. So roughly, including all those things, we are collecting about 25 essential metrics. We are collecting that, compressing at the source, and sending it to backend data source. Right. Okay, so metrics good, right? Initially, we wanted to capture metrics only, but OTel, since it is supports tracing as well, we started leveraging the same OTel collector for tracing as well, right? So there are a few configurations need to be updated, like to intercept the traces, then processing of the traces, then after that forward it to central endpoint. So what are those configurations? So OTel, which is running on local, it will have its own endpoint where you need, once you instrumented with your application with SDK, it will send the traces to the endpoint of the local, right, which will collect, process all those things. Then it will send it to central trace repository, which we are leveraging Tempo, right? So again, the Tempo is running on Google Cloud, where we are leveraging the storage present in that one, but Tempo is, again, open source is what we are using. And when on the local collector, you have a lot of customization option available, meaning like what is the process size you wanted to do, the compression, sampling of the traces, right? So all those things you can do at that local collector level itself, which will end up in consuming less resource for the collector and also the network bandwidth. Then third point, obviously, to collect the traces, you need to instrument your application with SDK library, and either you could do at the build phase or run phase, right? So we were leveraging the run phase mechanism, and basically using the custom pod annotation, and we are using that when an application pod tries to come up, it will inject the libraries into the application code, then all the configuration from the settings, the endpoint, all those things, it will get part of that. That's how it gets. Then the main thing is, right, since this is on the retail edge locations, and the same service, same application runs across hundreds of thousands of locations, right, with the same name. But from triaging perspective, how do we identify if an issue happens on particular state, particular state or particular region or particular retail location or particular customer? So all those things need to be captured. There are some configuration mechanism like, whatever attributes you need to collect, that service, the region-wise, everything you can customize in the hotel SDK library from a client and a server perspective, and that will be passed on part of the header and response that is cascaded to across all the hops. And through this mechanism, we'll get full visibility right from the user interface to the edge, all the way to the backend. So you can correlate the transaction all the way using the trace ID and span. Right. So when it comes to the tracing, I mentioned, we heavily talked about the resource consumption from the metrics perspective. Before enabling traces, we were like, okay, so we are almost like 600 kbps of the network bandwidth we already used. Only we have, small reg room available. So let's look into the traces, right? Fortunately, after enabling traces, the resource and network consumption, it was not that high, right? Because we are talking about this collector present on each and every retail location where there is not much volume. So due to that, the volume of each and every trace, right? And with all the compression mechanism, the network which was needed to pass all these traces to the central, not much, around 200, 250 kbps is what needed at respective location. So it worked out well. Negligible CPU, then bandwidth, then trace, obviously it gives correlation between the metrics, right? If your metrics behaving abnormally, due to any abnormality going in your application, you'll get alerted. And since all those data are present in the central backend, right, using Grafana or any other visualization tool for that matter, you can visualize the metrics and easily correlate the traces respective to that. So it's easy to identify the root cause analysis from the end-to-end tackling perspective. All right. So we talked about metrics, traces, then third pillar, logs, right? Yes, metrics. It will tell if there is a problem or not. You will get notified, right, using dynamic threshold mechanism or baseline or predictive analysis or whatever it is, right? We identify the problem, but how to triage and fix the issue? Yes, logging is very much important, right? And again, the same concern comes, and we started with the combination of FluentD and FluentBit. It's basically, again, open source solution, but it is supported by many commercial vendors as well. So all the application parts, it's instrumented with Hotel SDK library for logs, and FluentBit, which is a lightweight component, runs as a sidecar across all the application parts. It collects the logs, and that data will send it to FluentD, which is another component running within the local itself. It receives the log from across all the parts, right, running locally, and then it processes it, meaning it receives it and processes and compresses it, right? And we have done a lot of customization over there to reduce the log volume drastically by 60%. In the next slide, we'll quickly talk about that. So after that's aggregated, processed, filtering, all those things are done, then you can send it to your preferred centralized location. It could be Splunk, it could be Loki, or it could be any commercial vendor as well, right? You can use HCC token, which is a popular method of establishing the trust, then sending in the traffic. So that can be done. And this solution is leveraging FluentBit and FluentD to collect the application logs. For the user interface logs, we still leveraging OTel, right? So logs, as we all know, unless it is managed properly, lot of logs application can generate like a huge amount of volume, right? Unless it is properly managed, it will generate lot and it will end up with network consumption as well as pricing as well, right? So, and before we implement this solution, we have made certain things working along with our engineering partners. Okay, if you really want the logs to be shipped to your central location where it can be used for further all the processing, it needs to follow some standard, right? Number one, JSON formatting, right? It's not new. It is there in the industry for a long time, but still it is not very consistent. So we made sure to our engineering partners saying that to emit your logs in the JSON format with key value attribute, right? If it not followed the standard, we are not going to ship it, right? We are going to filter it in the FluentD itself. You won't be able to see, right? That we have made it. And then few other configurations like, okay, the logging, timestamp need to be present, proper exit and error code need to be present. So all those things we have done. And then moreover thing is, right, we are sending the logs, whatever is really needed from triaging perspective, meaning like, if any logs are enabled for debugging purpose, we know everyone looking at the that console, right? And it's enabled for certain purpose. And with the limited resources available, we cannot send everything. So debug logs, we are not forwarding it. Okay, then final thing is, yes, these logs are really helpful from triaging and alerting purpose if it is in a central location, right? So the optimization mechanism, since it can generate a huge amount volume of log, what we have done is FluentD, it supports compressing mechanism. So gunzip is the one which we have enabled at FluentD on the source. So before it sends any log to the central location, it is compressed. So that's one which drastically reduces the bandwidth. Then selective filtering, meaning like in K3's environment, you have infrastructure logs, right? You have security logs, you have application logs, everything. But what is really needed from user experience perspective, application logs. If application is behaving abnormally, that is main thing what we have done. So this solution, it supports a lot of filtering options, meaning like if your applications are running on a particular namespace, you can filter and configure to forward logs only from a specific namespace. Or even at the pod level, if you want to forward only certain pod logs or certain severity logs, all those mechanisms it supports on the FluentD level, and we have enabled that. This solution is basically, we are forwarding only the application related logs, not the the K3's infrastructure related logs, all the info related logs or debug logs, those are all filtered. Whatever is bare minimum needed, that's what we're finding. With all this compression, filtering, with the standardization of JSON thing, we were able to achieve about 60% of the reduction in the volume, which really helped our bandwidth consumption as well. So when I talk about that 650, around 650 kbps, what is being used? It is for metrics, traces, and logs as well. Right. So then next one is front-end observability, right? So yeah, you have workloads running, you are collecting metrics, all those things, but it is really important how customer is experience your application from these retail environments. And we mentioned about, we talked about the Web Vital metrics, right? It's a Google standard. although there are tons of metrics available, and from user perspective, there are certain things we are capturing, right? LCP, which is to measure the how to load a largest content in your application, how much that is taking, right? That basically that's a load time. And INP is responsive. So if a page is loaded, and if a user want to interact with your application, for example, in your dashboard, if they wanted to put your, put their user credential, how responsive that is. And then CLS is a stability, right? Once the page is loaded, how stable it is. Then the other things like the HTTP request right from the user interface, we are collecting all those things. So basically this mechanism, Hotel supports, there is an SDK which is specifically to capture the Web Vital metrics, right? And Google has its, again, open source webvital.json, which will collect all these metrics. So you have to embed those code snippet into the Hotel browser SDK, which will capture all these things. And the session level logging, right? So again, in the Hotel SDK, there is a logging component as well, which is instrumented part of it. And with the use of this, we are capturing the logging right from the user interface level itself. So if a browser crashes or if any error happens at the browser level, those data being captured along with the other details like facility code or session ID, all the key value attribute from the browser level, which is very useful if you wanted to track it a particular user level, that's being collected and shipped to Splunk or Loki, whatever the mechanism. So that will be helpful if you wanted to if you wanted to troubleshoot a particular geo level locations. Right. So since Hotel is instrumented at the UI level, and when a user starts using that, there is a trace ID gets generated, right? Since that is the starting point where the transaction started, it generates a trace ID, and that will get passed on along the way. Since you have Hotel instrumented at the UI, backend workload, all the way to the central could be on-prem or any of the cloud provider, that trace ID gets generated and it passed along all the way where all the spans get generated and it's all tied together, and we can in the central location, either temp or anywhere else, we can completely see the transaction along with all the spans. That includes the client and server side, and that is useful if you have all the data in one place. That can be used to graphically visualize the user click path, right? For example, 100 users logged into your application, and this is the response time. Among the 100 users, when they try to log in with their credentials, 95% of the users successful, 5% failed, or they closed browser due to whatever reason it is. So those kind of user journey, using this open source, we can provide it. So these are again the same results. Memory 63% reduction, 96 in the bandwidth, and log volume, right? So what we the lessons learned part of these things. Resource is one thing, CPU, memory, the storage is one thing, but network is the main thing, right? Since you depend upon a lot of service provider, there are not whole lot of available. We have to play with whatever we have. So design your solution in such a way, to collect what is bare minimum needed for your observability solution to work. Then after that, if you have additional resource available, then you can add on, additional things, which is nice to have. Those things you can add it, but start with bare minimum. And then logging, JSON format, right? We talked about it. And then integration planning, right? So meaning like once you instrumented that Hotel, from where you are going to really sending it, you have option to directly send it to Splunk or send it to your local collector, and which will kind of like aggregate, compress everything and send it to location. Then start with essential. This was what we talked about. This solution, the numbers, whatever I provided, it works well for if you collect around 25 critical metrics. Then another thing is, right, this solution, yes, it is tested on a production scale for a retail environment, but this solution and framework can be adaptable for other domains also. It can be healthcare, where retail pharmacy or minute clinics or any hospitals where you can collect the data locally, send it to your local aggregator component, and boom, send it to a central location. Similarly, for the telecom, then it works for energy and utilities or any financial institutions. So wherever you have a local environment where if you lose the network connectivity to the central, but you still want to serve your customers with a minimum functionality, yes, this solution works well. What's the future roadmap? Now, we collected all this data, all the data is present in one location, with manual correlation, yeah, you can do based upon what we have learned over the years. But in future, we can implement AI and machine learning on top of it, either with your open source available or any third party, and we can do predictive analysis, automatic correlation, and self-resolving. So again, these are the takeaways. With OTel, we can save the bandwidth, 96%, then memory 63, then full stack is available, and with the structured logging and customization, 60% of the reduction volume is achieved. Okay, that concludes. Thank you, everyone. We'll go to questions.